1.3 Properties of addition and subtraction of integers. 1.3.1 Closure under addition. We have learned that sum of two whole numbers is again a whole number. For example, 17 plus 24 is equal to 41, which is again a whole number. We know that this property is known as the closure property for addition of whole number. Let us see whether this property is true for integers or not. Following are some pairs of integers. Observe the following tables and complete it. So here in box, a statement is there, observation is there. 17 plus 23 is equal to 40. What is the result? The result is an integer. Minus 10 plus 3 is equal to what? Minus 7 will be there. Then it is an integer. So likewise you have to fill. What does you observe in the sum of two integers? Always an integer. Did you find a pair of integers whose sum is not an integer? Since addition of integers gives integers, we say integers are closed under addition. In general, for any two integers a and b, a plus b is an integer. 1.3.2 Closure under subtraction. So for addition, the two integers are always, whatever the result will be there will be the integer. So under addition, the integers are closed. Closure properties exist. Now 1.3.2 Closure under subtraction. What happens when we subtract an integer from another integer? Can we say that their difference is also an integer? Observe the following table and complete it. Now 7 minus 9 is equal to minus 2. Already it is integer. 17 minus 21. The result will be 38 plus 38. So again this is integer. So likewise you just go through and you will see what you do observe. Is there any pair of integers whose difference is not an integer? Can we say that integers are closed under subtraction? Yes, we can see that integers are closed under subtraction. Thus, if a and b are two integers, then a minus b is also an integer. Do the whole number satisfy this property? Do the whole numbers satisfy this property? You have to check. Now next point is 1.3.3 Commutative property. We know that the 3 plus 5 is equal to 5 plus 3 is equal to 8. That is, the whole numbers can be added in any order. In other words, addition is commutative for whole number. Can we say that same for the integers also? We have 5 plus in bracket minus 6 is equal to minus 1 and minus 6 plus 5 is equal to minus 1. So 5 plus in bracket minus 6 is equal to in bracket minus 6 plus 5. Are the following equal? Try this with 5 other pair of integers. Do you find any pair of integers for which the sums are different when the order is changed? Certainly not. We say that the addition is commutative for integer. In general, for any two integers a and b, we can say that a plus b is equal to b plus a. We know that the subtraction is not commutative for whole numbers. Is it commutative for integers? Consider the integers 5 and minus 3. Is 5 minus minus 3 the same as minus 3 minus 5? No, because 5 minus minus 3 is equal to 8 and minus 3 minus 5 is equal to minus 8. Take at least 5 different pairs of integers and check this. We conclude that subtraction is not commutative for integers.